Welcome to Tungal Online Classes. In the last class, we completed the synopsis of the gravitation topic. Today, we are going to discuss about the numericals. So, in the classroom exercise, we will discuss the second numerical. In the second numerical, they given that if the Earth is at 1/4 of its present distance from the Sun, the duration of the year would be. In generally, what is the duration of 1 year? The duration of 1 year is equal to 365 days. 365 days for the given distance of separation between the Sun to the Earth. Now, what they are saying that whatever the present distance of separation will be there in between the Sun to the Earth, that will be reduced to 1/4. That will be reduced to 1/4. Then what about the new time period of revolution of the Earth? So, this problem is based upon the Kepler's third law. Kepler's third law. What is the Kepler's third law? The square of time period of revolution is directly proportional to cube of semi-major axis. What is the Kepler's third law? The square of time period of revolution of any one of the planet is directly proportional to cube of semi-major axis. According to the given data, what they given, T1 is equal to 365 days, and we will assume that A1 is equal to A. What is the A1? Initial distance of separation between the Sun to the planet Earth. Now, that distance will be reduced to what? A2 is equal to A by 4. A2 is equal to what? A by 4. That will be reduced to 1/4 of the present value. Now, according to the Kepler's second law, I am writing that T2 square by T1 square, T2 square by T1 square is equal to A2 cube by A1 cube, A2 cube by A1 cube. So, here what is the A2 value? A by 4. A1 value is equal to A whole cube. AA will be getting cancelled. So, here 1 by 4 whole cube, that value is equal to 1 by 64. T2 square by T1 square, T2 square by T1 square. From this we will write T2 by T1 is equal to 1 by 8. T2 by T1 is equal to what? 1 by 8. But what value they are asking that? The new time period of revolution of the Earth. So that T2 becomes to what? T2 becomes to 1 by 8 of T1. T2 is equal to what? 1 by 8 of T1. So according to the given options, the correct answer is what? 1 by 8 of the present year. New time period is equal to what? 1 by 8 of the present year. What is the present year? 365 days. Like this we have to solve the numerical number 2. Next. Problem number 3, important one. So, this problem is based upon the Kepler's second law. What is the Kepler's second law? The radial vector which is joining the planet to the Sun will be sweeps out equal amount of areas in equal time interval. So, according to the Kepler's second law, we will write that dA by dt is equal to L by 2m. dA by dt is equal to what? L by 2m, which is equal to constant. Which is equal to what? Constant. Here, A will be representing the area swept by the radius vector, area swept by the radius vector, and T will be indicating what? Time duration. T will be indicating what? Time duration. So, in that formula dA by dt, A will be indicating what? Area swept by the radius vector, and T will be indicating what? Time duration. Now, coming to the given problem. So, in the given problem, they mentioned that the area swept by the line joining the Sun to the Earth from Feb 1 to Feb 7 is capital A. So, first we will write the amount of area swept by the radius vector. Area A1 is equal to A. Area A1 is equal to A. Now, we will write the time period value or time duration value. Time duration will be given by from Feb 1 to Feb 7. That means how many number of days? 7 number of days. How many number of days? 7 number of days. In 7 number of days, the radius vector will be sweeping the area in A. The radius vector will be swept how much amount of area? Capital A. Therefore, here I am taking the T1 is equal to 7 days. T1 is equal to 7 days. A1 is equal to A. A1 is equal to what? A. Now, what they are asking that then the area swept by the same radius vector from Feb 8 to Feb 28. So, here the second time duration value will be given. Second time duration value will be given from Feb 8 to Feb 28. That means 21 number of days. So, T2 value given by 21 They are asking simply A2 value is equal to what? So from that given formula we will write A1 by T1 is equal to A2 by T2. A1 by T1 is equal to what? A2 by T2. From this A2 is equal to, what is the A1 value? A into T2 value. T2 value is equal, directly we are writing 21 and T1 value is equal to 7. 7 4 ja, therefore, sorry 7 3 ja, therefore A2 is equal to 3A. A2 is equal to what? 3A. So that the amount of the area swept by the radius vector from Feb 8 to the Feb 28 is equal to how much? 3 times the initial area. Like this we have to solve this type of model problems. This type of problems are very, very important. Next one. Problem number 4. 2 satellites are revolving around the earth in the circular orbits of a same radii. Mass of the one of the satellite is equal to 100 times of the mass of the other. Then the time period of revolution of the satellites will be in the ratio of. See here. It is depends upon the Kepler's third law again. What is the Kepler's third law? According to the Kepler's third law, we will write the square of the time period of the revolution is directly proportional to semi-major axis. Here, T will be, the time period of revolution will be independent of mass of the satellite. Time period of revolution will be what? Independent of the given mass of the satellite. Since both are revolving in the same circular orbit, so that their semi-major axis distances will be remain same. Therefore, if A1 is equal to A2, T1 is to T2 is equal to what? 1 is to 1. So, conceptual problem, time period of revolution of a satellite will be independent of the mass of the given satellite. So, that is about numerical number 4. Next. Problem number 6, it is also important one. So, they given one diagram. The planet Mercury is revolving around the sun in the elliptical orbit as shown in the figure. Its kinetic energy will be maximum at which position? So, problem number 6. In this problem number 6, elliptical path is given. Here sun will be there. So, they mentioned some of the points here. A, B, C and D. So, here in the elliptical orbit they identify 4 different points A, B, C, D respectively. They are asking that at which point kinetic energy will be maximum. See here, already I told the point A will be very closer to the sun. The point A will be very closer to the sun whenever the distance of separation will be minimum. Whenever the distance of separation will be minimum, at that point velocity or the speed value will be maximum. Already this type of condition we wrote, angular momentum will be constant, m into v into r will be constant. As a result we will write v1 r1 is equal to v2 r2. v1 r1 is equal to what? v2 r2. Since the distance of separation between the sun to the planet will be minimum, at that position it is having the greater speed, so that at the point A kinetic energy will be maximum. At the point A kinetic energy will be maximum. So, conceptual bit, very, very important one. So, like this we have to solve the problem number 6. 7. Problem number 7. The planet of mass capital M is revolving around the sun in the elliptical orbit. One planet will be considered whose mass is equal to capital M, which is revolving around the sun in the elliptical orbit. If its angular momentum will be given by capital J, then the area swept per second by the line joining planet to the sun will be. See here, this problem will be related to the Kepler's second law. What is the Kepler's second law? According to the Kepler's second law, the line joining vector between the planet to the sun will be sweeps out equal amount of areas in equal time intervals. According to that, we will write dA by dt is equal to L by 2m, which is equal to constant. So, this is the general formula we wrote in the synopsis according to the given data. So that here in the given problem, instead of the capital L, the angular momentum will be represented by capital J. So, what they mentioned here, angular momentum will be measured as a capital J. So, they are asking what value? They are asking the area value. So, we have to calculate the area. From this formula we will write that A by T. A by T. Why we wrote 1 instead of T means they are asking what? Area swept per second. So they taken the time value for 1 second only. Therefore, A by 1 is equal to, in the place of capital L, what we have to write? Capital J by 2 into mass of the planet will be measured as capital M. Therefore, area swept by the line joining vector between the planet to the sun will be given by A is equal to capital J by 2M. That is about the numerical number 7. Next, problem number 8. The earth is revolving around the sun in the elliptical orbit if there are small printing mistake will be given. So that if OA by OB, OA by OB. See the problem number 8. If the earth is revolving around the sun in the elliptical orbit, if there small printing mistake will be given, if OA by OB is equal to X, they given SA by SB, that is wrong. So what the data they given that OA by OB is equal to X. This is the right information. OA by OB is equal to X. Then the ratio of speeds of the earth at B and A will be. So the given diagram is like this. Elliptical orbit. So here sun will be there. This point will be taken as B and this point will be taken as A, and here only this point will be, they will be taken as again O. At the point O, sun will be there. Now they are asking what the ratio of speed of the earth at B and A will be. Already we told, according to the Kepler's second law, for a revolving planet around the sun, its angular momentum value will be constant. Angular momentum formula is equal to what? L is equal to m into v into r is equal to what? Constant. Mass of the planet is always constant. From this we will write v into r is equal to constant. V into r is equal to what? Constant. Already this concept we discussed. From this we will write v max into r minimum is equal to V minimum into R max. From the given diagram, so the point B will be closer to the sun, so that at the point B, the speed will be maximum, and the point A will be far away from the sun, so that at the point A, the speed will be minimum. So that from this information we will write VB into this distance of separation is equal to OB, VB into this distance of separation is equal to OB, and this minimum speed is equal to VA into OA. Therefore, VB by VA is equal to OA by OB. But they given the value OA by OB is equal to X. Therefore, VB by VA is equal to X. So that is the required answer for the problem number 8. Next one. Problem number 10. If A is the aerial velocity of the planet of mass capital M, its angular momentum will be. It is also direct problem. So this is problem number 10. Already we know that dA by dt is equal to L by 2m. dA by dt is equal to what? L by 2m according to the Kepler's second law. Which value they are asking? They are asking the angular momentum value. So here also we are assuming that the time will be taken as a 1 second. So from that I will write A by 1 is equal to L by 2m. Therefore L is equal to 2 into m into A. L is equal to what? 2 into m into A. It's a very direct problem. So that is L is equal to what? 2 into m into A. That is about numerical number 10. Number 12, it's a very important model. Let capital A be the area swept by the line joining the earth and the sun during the February 2012. Then the area swept by the same line during the first week of that month will be. So here they will given that let capital A will be the total area swept by the line joining vector which is drawn from the sun to the planet earth in the month of February 2012. So in the February 2012, how many number of days will be there? 2012 will be completely divided with the number 4, so that this 2012 will be the leap year. 2012 will be the leap year, so that this February month will be consisting of 29 number of days. February 2012 will be consisting of how many number of days? 29 number of days. So that from this we will get one data. Initial area is equal to A1 is equal to A, and initial time period is equal to what? T1 is equal to 29 days. Now what they are asking, that the area swept by the same line during the first week of that month will be during the first week, so that the second time will be is nothing but 7 days. 1 week means what? 1 week is consisting of 7 number of days. Second time period value is equal to 7 days. We have to calculate the area covered by the line joining vector between the sun to the planet in the 7 days. According to the Kepler's second law, we know that dA by dt is equal to constant. dA by dt is equal to what? Constant. From this we will write A1 by T1 is equal to A2 by T2. A1 by T1 is equal to what? A2 by T2. What is the A1 value? A, and what is the T1? 29. And A2 value we have to calculate, and the T2 value is equal to 7. Therefore, A2 is equal to 7A by 29. Very important model. A2 is equal to what? 7A by 29. Like that we have to solve the problem number 12. Next, problem number 13. A satellite is moving in the circular path of radius small r around the earth, has the time period of capital T. If the radius is slightly increases by 4%, then the percentage change in the time period will be. So that according to the Kepler's third law, what we will write? T square is directly proportional to A cube or R cube. T square is directly proportional to A cube or R cube. From this I will write T is directly proportional to R power 3 by 2. T is directly proportional to what? R power 3 by 2. From this we will write the fractional change in, or the percentage of change in time period is equal to, its power value is equal to what? 3 by 2 into delta R by R into 100. So from this, whenever time t is directly proportional to R power 3 by 2, the percentage of change in time period will be getting by this formula. Delta t by t into 100 is equal to what? 3 by 2 into delta R by R into 100. So what is the percentage they given? The radius will be slightly increases by 4%. So delta R by R into 100 value will be given. This value is nothing but 4% will be increases. Therefore, delta t by t into 100 is equal to 3 by 2 into 4%. 2 2s are therefore 6%. The time period will be increases by how much percent? 6%. So that is about the numerical number 13. Next one. Problem number 15. The distance of Neptune and Saturn from the Sun are respectively 10 power 13 and 10 power 12 meters, and their time periods are respectively given by Tn and Ts. If their orbits are circular, then the value of Tn by Ts is. It is also depending upon the same formula. That is a problem number 15. T square is directly proportional to R cube. The square of time period of revolution is directly proportional to what? R cube. So what is the distances they mentioned means? R1 is equal to 10 power 13. R2 is equal to 10 power 12. R1 is equal to 10 power 13. R2 is equal to what? 10 power 12. They are asking Tn by Ts values. So that Tn square by Ts square is equal to R1 by R2 whole cube. Tn square by Ts square is equal to what? For the Neptune N, for the Saturn S. Tn square by Ts square is equal to what? R1 by R2 whole cube. So here, this is a 10 power 13 by 10 power 12 whole cube. Whole cube. See here, this value is equal to 10 cube. So Tn square by Ts square is equal to what? 10 cube. Now, if you simplify, you will get Tn by Ts is equal to 10 root 10. Tn by Ts is equal to what? 10 root 10. So that is a numerical number 15. See the next problem, problem number 18. If a graph is plotted between the t square and the r cube for a planet, then its slope will be, they given one graph which is drawn in between the physical quantities t square as well as r cube. The given graph will be the straight line which is passing through the origin. Then they are asking that what is the slope of that graph or curve. So in generally we know that if any one of the planet will be revolving around the sun in the circular orbit, we have to calculate the time period value. For that, the centripetal force will be provided by the gravitational force. Centripetal force will be provided by the gravitational force. What is the centripetal force here? Mr omega square. Gravitational force is equal to gmm by r square. M will be getting cancelled. So here 4 pi square by t square is equal to gm by r cube. 4 pi square by t square is equal to what? Gm by r cube. So I will write t square is equal to 4 pi square by g into m into r cube. T square is equal to what? 4 pi square by gm into r cube. So here t square term will be taken along the y axis, r cube term will be taken along the x axis. So that it is in the form of y is equal to mx. Y is equal to mx. So that in the place of m, what is the factor will be there here? 4 pi square by gm. So that the term 4 pi square by gm will be indicating the slope of the given straight line. Slope of the given straight line. So that the first option will be the correct. Important model. Next. See the problem number 19. Two different artificial satellites orbiting with the same period around the earth having the angular momenta in the ratio of 2:1. So then the ratio of masses of the satellites is, first we will write what is the given data here. L1 is to L2 is equal to, they given by L1 is to L2 is equal to what? 2:1. And what value they are asking? The ratio of masses. But one condition they given, that both the satellites are having the same time period. So according to the Kepler's second law, we know that square of the time period of the revolution is directly proportional to cube of semi-major axis or a cube of the radius of the orbit. If a t value will be constant, radius is also constant. T value is also constant means radius is also constant. Now, from the angular momentum formula, what is the angular momentum formula? mvr, m into v into r. So here I will write L is equal to m into v means what? R omega into r. So that here m r square omega means what? Again 2 pi by t. R constant, t constant, therefore L is directly proportional to m. Angular momentum is directly proportional to m. If L1 comma L2 are in the ratio of 2:1, the masses are also in the ratio of 2:1. So m1 is to m2 is equal to what? 2:1. So like this we have to solve the numerical number 19. Next, problem number 20. The ratio of Earth orbital angular momentum to its mass is 4.4 into 10 power of 15. Then the area enclosed by the Earth orbit approximately is, see here, what the given data they given. Problem number 20, they given that the ratio of angular momentum to the mass L by m value they given. L by m value is equal to 4.4 into 10 power 15. 4.4 into 10 power 15. They are asking that the area enclosed by the Earth orbit approximately is. So it is based upon the Kepler's second law. What is the Kepler's second law? Again, dA by dt is equal to L by 2m. dA by dt is equal to what? L by 2m. What value they are asking? Area value they are asking. So that I will write A by T is equal to what? 1 by 2 into L by m. 1 by 2 into L by m. We need the area value, therefore 1 by 2 into capital T into L by m. 1 by 2 into T into L by m. So substitute all the values 1 by 2. What is the T means? The time period of the Earth, that is equal to what? 365 days. T value is equal to what? 365 days. 1 day is equal to 86,400 seconds, and L by m value will be given by 4.4 into 10 power 15. 4.4 into 10 power 15. If you simplify, you will get the result 7 into 10 power 22 meter square. If you simplify that data, you will get the answer as 7 into 10 power 22 meter square. So that is a numerical number. Number 21. A geostationary satellite is orbiting the Earth at a height 6r above the surface of the Earth. So a geostationary satellite will be revolving around the Earth at what height? At a height of h1 is equal to 6r. h1 is equal to what? 6r from the surface of the Earth. From the surface of the Earth. Next, where r is the radius of the Earth. The time period of another satellite which is revolving around the Earth at a height of 2.5 r from the Earth's surface is. So initially, which type of satellite? They mentioned that geostationary satellite. For the geostationary satellite, time period is equal to what? 24 hours. Time period is equal to what? 24 hours. And the second satellite will be at a height of 2.5 r from the Earth's surface. From the Earth's surface. But according to the Kepler's third law, while you are writing the formula for the time period, we are writing that T square is directly proportional to R cube. T square is directly proportional to what? R cube. What is the R? Distance of separation between the satellite to the center of the Earth. Center of the Earth. So that for the first case, R1 value is equal to 6r plus r, that is equal to 7r. For the second case, R2 is equal to 2.5r plus r, that is equal to 3.5r. Now, we will write according to this formula, T2 square by T1 square is equal to R2 by R1 whole cube. R2 by R1 whole cube. What is the R2 value? 3.5r. R1 is equal to 7r whole cube. So this is the 2 times, that value is equal to 8. So T2 square by T1 square is equal to 8. T2 square is equal to 8 into 24 whole square. 24 whole square. If you simplify, you will get T2 is equal to what? 6 root 2 hours. If you simplify this one, you will get T2 value is equal to what? 6 root 2 hours. So that is about the numerical of 21. Coming to the problem number 22. Important one. If F suffix G and F suffix E are gravitational and electrostatic forces between the two electrons which are placed at a distance of 0.1 meter, then they are asking the ratio of gravitational force to the electrostatic force in the order of. Very, very important. See here. According to the problem number 22, they mentioned that two electrons will be taken. These 2 electrons are separated by a distance of 0.1 meter. 0.1 meter. So if these 2 electrons are separated by some distance of separation, between those 2 electrons, gravitational forces are present as well as electrostatic forces also present. For the electron, mass of the electron is equal to 9.1 into 10 power minus 31 kg. If you take the electron, the mass of the electron is equal to what? 9.1 into 10 power minus 31 kg. And the charge of the electron is equal to 1.6 into 10 power minus 19 coulomb. For the electron, the mass is equal to how much? 9.1 into 10 power minus 31, and the charge value is equal to what? 1.6 into 10 power minus 19 coulomb. Now, how can we calculate the gravitational force as well as the electrostatic force? So, first we will know the gravitational force formula. F gravitational is equal to G into m1 m2 by r square. G into m1 m2 by r square. So, what is the G value here? 6.67 into 10 power minus 11. 6.67 into 10 power minus 11. Both are the electrons only. That means their mass will be remain same. Directly I am writing that. That is 9.1 into 10 power minus 31 whole square by r square. Whole square by r square. So, this is the value of the gravitational force of repulsion between the two electrons. Now, we have to calculate the electrostatic force. F electrostatic force formula 1 by 4 pi epsilon naught Q1 Q2 by r square. 1 by 4 pi epsilon naught Q1 Q2 by r square. This 1 by 4 pi epsilon naught will be the proportionality constant. Its value is equal to 9 into 10 power 9. 9 into 10 power 9, and both are the electrons only. That means their charge will be remain same. Therefore, 1.6 into 10 power minus 19 whole square by again r square will be there. Let it be equation number 2. Now, what value they are asking? Fg by Fe. Fg by Fe is equal to, in the denominator r square will be getting cancelled. So that 6.6 into 10 power minus 11 into 9.1 into 10 power minus 31 whole square by proportionality constant 9 into 10 power 9 into, so this value 1.6 into 10 power minus 19 whole square. If you simplify that value, you will get, they will be in the order of 10 power minus 43. 10 power minus 43. Like this we have to calculate the numerical number 22. Numerical number 22. Very, very important one. Next. Remaining bits are the theory bits. You solve them. Problem number 32. One more important problem. 32. 6 particles each of mass small m are placed at the corners of a regular hexagon of edge length small a. If a point mass m0 is placed at the center of the hexagon, then the net gravitational force on the point mass is. See here, we will take one regular hexagon. That means all the sides will be remain same. All the sides will be remain same. So at the center of the hexagon, we are placing the point mass m0. And at 6 corners of the given hexagon, we are placing the identical masses. Already we know that gravitational force will be the attractive force. So that this mass m0 will be attracted by equal magnitude of the forces in all the directions. If you look at this diagram, let it be 1, 2, 3, 4, 5, 6. The force 1 will be balanced by the force 4. Force 1 will be balanced by the force 4. Force 2 will be balanced by the force 5. 3 will be balanced by the 6. Therefore, the net force acting on the point mass which was kept at the center of the regular hexagon will be is equal to 0. Since all the forces are having the equal magnitudes and they will be acting in the opposite directions. Hence, all these forces are cancelled together. Hence, the resultant force acting on the point mass is equal to what? 0. That is our the. A planet of mass 3 into 10 power 26 kg moves around a star with a constant speed of 2 into 10 power 6 meter per second in the circle of radius 1.5 into 10 power 12 meter. The gravitational force acting on the planet is, direct formula 34. Mass of the planet will be given by, mass of the planet is equal to what? m is equal to 3 into 10 power 26 kg. Velocity v is given by 2 into 10 power 6 meter per second, and radius is equal to, radius of the circular path is equal to what? 1.5 into 10 power 12 meters. If any one of the planet is revolving around the sun or stars, centripetal force is acting on the planet, so that centripetal force acting on the planet is equal to mv square by r. So we have the data 3 into 10 power 26. What is the v value? 2 into 10 power 6 whole square by r value 1.5 into 10 power 12 meter. If you simplify, you will get the answer as 8 into 10 power 26 Newton. So third option will be the correct. So like this we have to calculate the centripetal force which is acting on the given planet. Next one, 35. The force on 1 kg mass on earth of radius r is 10 Newton. So what they taken here? Initially a mass will be given, m1 is equal to 1 kg, and the force acting on that mass is equal to F1 is equal to 10 Newton. F1 is equal to what? 10 Newton. Next, then the force on a satellite which is revolving around the earth in the mean orbit of 3r by 2 will be. So here an object will be placed on the surface of the earth. So over the object how much force is acting? 10 newtons, and one satellite will be revolving around the earth with the mean radius of 3r by 2. Then what is the force acting on that satellite will be? So here the mass of the satellite will be taken as 100 kg, and initial radius r1 is equal to r, and final radius is equal to what? 3r by 2. We have to calculate F2 value. So here F is directly proportional to what? M by r square. F is directly proportional to what? M by r square. So according to the gravitational force of attraction, F is equal to gmm by r square or small r square. So F2 by F1 is equal to m2 by m1 into r1 square by r2 square. What is the m2 value? M2 value will be 100, m1 is equal to 1, and r2 value is equal to 3r by 2, r1 is equal to r whole square. R will be getting cancelled. So 100 into 3 square means what? 9 by 4, 25. If you simplify, you will get 4.4 into 10 square Newton. 4.4 into what? 10 square Newton. So like this we have to solve the problem number 35. Next one, problem number 36. So important one. See the next problem 36. It's a very important. A rocket is fired from the earth to the moon. The distance between the earth and the moon is small r, and the mass of the earth is 81 times the mass of the moon. Then the gravitational force on the rocket will be 0 when its distance from the moon is. So this is the concept of a null point. What is the null point? It means the point at which resultant gravitational field intensity is equal to 0 in between the two given masses. The formula for the null point is x is equal to r by under root of m2 by m1 plus 1. What is the formula for the null point? The position of the null point which is measured from the smaller mass will be given by x is equal to small r by under root of m2 by m1 plus 1. So here we are assuming that the mass of the moon is equal to m1 is equal to m, mass of the earth is equal to what? M2 is equal to 81 m. Since they mentioned that mass of the earth will be 81 times greater than the mass of the moon, they are asking that at what distance which is measured from the moon, the resultant gravitational field is equal to 0. For that, we are using the formula for the null point. We are using the formula for what? Null point. What is the formula? X is equal to small r. What is the small r? Distance of separation between the two planets by under root of m2 by m1 plus 1. r by under root of, what is the m2 value? 81m by m plus 1. So r by under root of 81 means what? 9 plus 1. So therefore x is equal to what? R by 10. So at a distance of r by 10, which is a measure from the moon, the resultant gravitational field intensity will be is equal to what? 0. So these are the numericals for this class. Tomorrow we will discuss the remaining number of numericals. Thank you.